Hello, so in the final patch for this early part of mus119, we're going to make something that broadly resembles one octave of a keyboard, that when you click on a button you get a note of a certain duration from a sine wave. You'd think that was quite easy to do, but there's quite a lot to it. So let's begin, and I'll save this example 6 notes. If you remember from the previous example, in order to get some audio I need an object box with a DAC. In order to get sound out I need an oscillator, and at some point I need to multiply the amplitude of my oscillator, and at some point I need a frequency going into my oscillator. So now I need to think, what is the frequency of a note? Let's do a middle C through to for one octave. Now you can find frequency charts for the equally tempered scale online, but that's a bit of a hassle. Actually, in class we're going to figure out how to make the equal tempered scale. You're going to have to read up about the 12th root of 2. For some of you this will be enormous fun, for others it won't be. But there's a simple way, and so we'll look at the simple way today, and over the course of the class we'll also figure out the more complex way to understand precisely what the equal tempered scale actually is. We're going to use MIDI notes. Now MIDI notes come from a keyboard, and why don't we play the keyboard? We could do this. So it's an object box with notes in, and the MIDI keyboard has, when you push a key, you have the note number coming out of the left inlet, you have the velocity that you hit the keyboard with coming out of the middle inlet, and you have the MIDI channel number coming out of the right hand outlet. If I put number boxes with these first two and I hit my keyboard, I get absolutely nothing. So I do need to check my preferences in media MIDI settings. Oh, well, there's no input device, so I'll just get my input device from my MIDI port. For you it'll be very different, and we'll go through that in class, and that's why we have lessons in the lab. We'll also make sure that you're using the right audio driver. So now when I press middle C I should get 60, and you'll note that I get the volume of the key, which can go from 0 to 127 when I really hit it, to something quite quiet when I just gently tap the keyboard. And when I take my finger off the key I get a note off, which is a note on with a velocity of 0. So I can use that quite simply to drive my volume. So I first of all need to convert my MIDI note 60 to a frequency, and there's an object box called M2F, MIDI to frequency. So that does all the complicated maths for you, and believe me, it is complicated. And 60 is 261.6, and the A that the orchestra tunes from, and we know, is 440. Put that into the oscillator. Now this number is going between 0 and 127, so why don't I very simply just divide by 127, and I get numbers between 0 and 1. So if I put that in there like that, make sure I'll put my DSP off for now, and I will just add an additional volume control and multiply everything again by 0.1 just to make sure that it's really quite quiet and not going to blow us all up. Turn the DSP on, Okay, we've got a keyboard. But the issues there are you hear glitches as it suddenly goes from 0 to a number and back to 0 again. And of course it's entirely monophonic. So if you wanted to make a polyphonic keyboard, you'd have to figure out what happens when I actually play 2 notes instead of 1. Again, that's for potentially some later classes, actually in later years. But those of you who are interested, there are examples of polyphonic synths in the USSS toolkit for you to have a look at. What we'll do right now is tidy this up a little bit and get rid of the keyboard uses. We're going to build this so that you could play this just from your laptop without having an external keyboard. So I know that the number 60, a message box, put message, the number 60. If I hit that, I get my frequency. So I could build my keyboard with 12 message boxes. So I'll duplicate that to make it look like a keyboard. Laborious, I know, but we could do it like this. C, D, E, F, oops, C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A, B flat, C. So I want 61. '62, '63, '64, '65, '66, '67, '68, '69, '70, '71. All of these need to join up to here. There are some very useful ways using what's called sends and receives to get rid of these lines. And I'll show you that in classes later on. So I could play my keyboard now. Notice this frequency is changing every time I move up the chromatic scale, just as we need, going to an octave above middle C. An octave above middle C. It's good that I remember what an octave is. Okay. So every time I hit one of these, I now want to raise the volume. And we're going to look at one of the most complicated but most versatile of envelope objects now. And this is called the vline object. Just goes in a box and its output goes to a multiply. And it sends a message to it receives a message containing an envelope. If you have a look at the help file, it says generates linear ramps whose levels and timing are determined by messages you send it. The messages consist of a target value, time interval and an initial delay. So let's just remind ourselves: target val, time value, initial delay. Double check that. Target, time, initial delay. Target, time, initial delay. So 3 values in a message box. So I want to put a message box and I want to start with a target value of 0, time value of 0, and an initial delay of 0. This is a message box with multiple messages in it, and you can make multiple messages by having a comma after your messages. So that's going to go 0, 0, 0. And now I want to go to a target value, 0.5, so half volume, in a time value. Now the time value will be in milliseconds, so let's do something quite quick, 1/4 of a second. And my initial delay, well, I want it to go to 0.5 immediately. So initial delay of 0. And so I'm going to create a ramp that goes 0, 0.5, back to 0 again. So my final command will be go back to 0, take 1/4 of a second, but here's where it's really important. How long do I have to wait to do this particular command? Well, I have to wait that long, because it's got to do that first in 250 milliseconds, and then it's going to do this ramp after 250 milliseconds. We'll go through this all again in class because this is really important. So I could put a bang here, and this is my note. Let me just make this bigger, give it an interesting color. We're probably good to go. Select my, get into edit mode of course, select my 60. So up to 0.5 in 250 milliseconds, wait 250 milliseconds for that to happen, and then over 250 milliseconds go back down again. So all I need to do with my notes now is put them here. And I know you're sitting watching this video here, and I should be filling the time in with some gags or something like that, but look at this mess. Okay, this gives you the idea. Notice we got a click when I was playing this too fast, because it was still doing this when it did the next suddenly start at 0. So that's just something you have to bear in mind. Finally, I'll just edit this and show you how to get rid of all these lines here. If we get rid of these number boxes for now, we put a number box with a 60 and check the, and that's a shame. Why can I not do that one? We could do send note. Send is in an object box. The name is note, and then with the M to F we could have receive note, and that way all this here could be hidden. Just join that up like that, and my 60, 61, and my whole keyboard. So I can build my keyboard, but put this away somewhere where I don't need to see it. So now we have some basic audio with some control of amplitude, and we're beginning to really get going with PD.